Glass, the perfect combination of sand, gypsum, soda ash, limestone, and dolomite. A product described as a rigid, uncrystallized liquid. A product known as glass. PPG operates several multi-line float glass plants and is the largest glass manufacturer in North America. The typical plant covers an area of 630,000 square feet and every day, 7 days a week, produces approximately 1 million square feet of glass that is further processed by our customers for use in homes, buildings, cars and trucks, aircraft, and a wide range of other applications. As in any glass manufacturing plant, the process starts here, in the batch house. Every day, raw materials are brought into the plant from as far away as Wyoming by rail and by truck, offloaded onto a conveyor, which transports them individually to their respective storage silos. The actual batching process begins when each material is transferred from its silo, weighed, mixed, and conveyed to the charging end of one of the plant's 2 melting furnaces. A glass melting furnace is a large brick structure, much like an old-fashioned baking oven, where batch material and cullet, crushed glass, are melted to form liquid glass. Sand, which is by far the major ingredient in glass, normally doesn't melt until its temperature reaches 3,000 degrees Fahrenheit. However, when it's combined with other ingredients in the batch, sand melts at temperatures below 3,000 degrees Fahrenheit. As the batch materials enter the furnace, preheated air is forced into the chamber by large fans. The preheated air combines with jet streams of natural gas to produce torch-like flames that spew out across the batch, causing it to melt in a matter of minutes. After the batch is completely melted, the fining process begins. This process allows the bubbles that form during the melting process to rise to the surface of the glass and escape into the furnace's atmosphere. Once the fining process is complete, the glass travels into the tank's forming chamber and through an opening called a canal and into the forming operation known as the bath. This process is based on the fact that liquid glass floats as it is hardening on a bath of liquid tin. Toothed wheels called stretch machines are used to further alter the glass ribbon's thickness and width. Heating elements located above the stretch machines also control the thickness of the glass as it moves through the bath to the exit end. Here, at its final width and thickness, the glass is cooled down by a series of water coolers and safely lifted from its tin bath onto the main line's conveyor. When the glass first comes out of the bath and moves into the Lear, it's been cooled down to about 1,000 degrees Fahrenheit. The Lear's job is to further cool down the glass at a controlled rate in order to ensure that proper stresses are put into the glass to make it cut well. After cooling, the glass comes out of the Lear at about 350 degrees Fahrenheit and is further cooled down by large open-air fans to about 200 degrees Fahrenheit. As the glass moves through this cooling down area, it is carefully inspected prior to the cutting operation. But first, the glass passes under a machine which drops a special powder on its surface to provide a separation medium between each piece of glass.